Today we will deal with a small sample test. Now, when small sample size is large, that is, when the sample size is large, that is when n is greater than 30, we have seen that the test statistics are normally distributed. So when n is less than 30, that is when the sample size is small, we have to use the test statistic that follow a normal distribution. Now here in this scenario, we use usually we use normal distribution, students t-test and f-test. So here we are going to learn about how to test a test statistic using a student's t-test, f-test and f-test. Now first let's move on to students t-test. Now there are certain assumptions regarding students t-test. So the assumptions are population should be normally distributed, standard deviation of the population is unknown, and the sample size is small, that is usually less than 30. Now in a t-test, to test a single mean, what we use is the standard procedure where the first step is to set up a null and an alternative hypothesis. So the null hypothesis here is given as mu equal to mu naught. H1, the alternative hypothesis are given as follows: mu greater than mu naught, mu less than mu naught, or it could be mu not equal to mu naught. Then our next step is to fix a level of significance, that is alpha, and based on H1 and alpha you have to obtain a critical value, and usually the critical values are T alpha or minus T alpha or T alpha by 2. That is, if this is your alternative hypothesis, then your critical value will be T alpha. If this is your alternative hypothesis, then it is minus T alpha, and if H1 mu is equal to mu naught, then your critical value will be T alpha by 2. Now the values of all these you will get it from the T tables. Now the fourth step is to set an appropriate test statistic. Now the appropriate test statistic for t-test is t is equal to x bar minus mu naught divided by s into root n minus 1. Now here this test statistics t follows a student's t distribution, and here x bar is the sample mean, mu naught is the population mean, s is a sample standard deviation, and n is the sample size. Now the conclusion is that you have to compare the value of the test statistic, that is what you have calculated, that is the t calculated over here, should be compared with your critical value, and you have to come to a conclusion. That is, if h1 mu is not equal to mu naught, then you have to reject h naught if modulus t is greater than T alpha by 2. If this is the scenario, then you have to reject h naught if modulus t is greater than T alpha. And if this is the alternative hypothesis, then you have to reject h naught if modulus t is less than minus T alpha. So that was the first test regarding testing a single mean. Now let's have a look at the t-test for the difference of means. Now here also you are setting up a null hypothesis and an alternative hypothesis. So the null hypothesis here is h naught mu 1 is equal to mu naught. The corresponding alternative hypothesis are given over here. We are fixing a significance level alpha based on h1, that is based on the alternative hypothesis and the significant level alpha. We obtain a critical value, and the critical values are given as follows, and these values can be found out from your t tables. Now the fourth step is to find out the t statistic. Now the t statistics is given as x1 bar minus x2 bar the whole divided by n1 n1 s1 square plus n2, sorry, this is s2 square, you should correct this, s2 square divided by n1 plus n2 minus 2 multiplied by 1 by n1 plus 1 by n2. Here this test statistic t follows a student's t distribution. Now your conclusion is that you have to compare the t with your test the critical values, that is T alpha by 2, T alpha and minus T alpha. So again, this is something that you have done you know, for the large sample test also, so I'm not going to repeat it anymore. So that was the test for difference of means. Now it is F test. Now in the F test also you have to set up a null hypothesis and an alternative hypothesis. Now the specialty of F test is that now till now the last two tests were concerning about mean. Now here it is a bit different. Now this is usually it is called F test, or it is also called equality of two population variances, or you can call it as F test for the ratio of variances. Okay, so it is concerned, or it is something related to the variances. Now, that is what you have to keep in mind. Now, while setting up a null hypothesis, usually students do make a mistake while setting up a null hypothesis, thinking that this is something related to mean. No. So their null hypothesis is nothing but sigma 1 is equal to sigma 2, and the corresponding alternative hypotheses are given as follows. Then you have to fix a level of significance that is alpha, and again you have to fix another significance level called as 1 minus alpha. Now, based on the alternative hypothesis and the critical and the significance levels alpha and 1 minus alpha, I forgot to write the 1 minus alpha over here, you have to obtain a critical value. So the critical value is as follows: f alpha or f1 minus alpha, or it could be f n1 minus 1, n2 minus 1 alpha by 2, f n1 minus 1, n2 minus 1, 1 minus alpha by 2. Now these two are related to associated with this alternative hypothesis. Okay, now till now you had only one critical value over here, but we are like floating down two critical values, and this is associated with the last alternative hypothesis. Now let's have a look at the test statistic. Now this is how your test statistics look like for the F test. F is equal to n1 s1 square divided by n1 minus 1, n2 the whole divided by n2 s2 square divided by n2 minus 1. And here this test statistics follows F distribution. I'm really sorry, this is not student. So here this test statistic follows F distribution. Okay. Now, let's have a look at the conclusion. Now, the conclusion is that we have to compare the value of the test statistic with the critical value and arrive at a conclusion. Now, the value of the test statistic F, if it is greater than what we have calculated from the tables, that is, again you will have an F table so from there you will get these value for fn1 minus 1 into n2 minus 1 alpha by 2. And you can reject h naught if this is the scenario, and if the alternative hypothesis is h1 sigma 1 not equal to sigma 2. Also you have to check whether f is greater than this fn1 minus 1 n2 minus 1 1 minus alpha by 2. Then if the alternative hypothesis is sigma 1 greater than sigma 2, then you can reject h naught if f is greater than f alpha. And again if the alternative hypothesis is sigma 1 less than sigma 2, then you can reject h naught if f is less than f1 minus alpha. So that is all about the small sample test. So I hope you have understood. Thank you.